Hello guys, hope you all are doing great. Welcome back to the channel. It's me Nitin. Today we are going to discuss the continuation of awesome problem. Before diving into the problem, we want to discuss the two-pointer approach. To understand the two-pointer approach, let's discuss a small problem and understand that, then we can do the awesome problem. So let's start. So here is the problem statement. We have an array of integers and with the target number t. We have to find the array which sum a of I plus a of j equal to t. So this is the array and this is target number. Array, we actually know that the sum of 2 plus 3 is 5. Also 4 plus 1 equal to 5. Only possible answer is 2, 3 and 4, 1. So how we can find the answer? This is similar to before we discussed in the part 1. We can do using hash map. So find the efficient solution. We just want to understand the two-pointer approach. We have the array 2, 4, 6, 1, 9, 3. Before dive into the two-pointer approach, we should do sort the array. The array should be sorted. Then after the sorting, array become an array look like this. And we are considering two pointers like int I and j. And we are assigning the initial value of I equal to 0 and pointer j equal to the length of array minus 1, because the last position we are assigning to the j pointer. The j pointer should become the length of array minus 1. The n is actually length of array. Then we are putting the first pointer here I and second pointer here j. Just consider the sum of I and j equal to target. We are checking the condition. If 1 plus 9 equal to 5, no. Then what to do? Because this answer is actually 10. 10 is greater than 5. So we should decrease in the j pointer. Selecting the pointer and moving to here. So what is right now? Now we are actually decreasing the j pointer. Initially we are assigned j equal to 5, right? Previously j equal to 5 and I equal to 0. So look here carefully. We have I pointer, we have j pointer, we have the sum value a of I plus a of j. Initially the I value equal to 1 and j value equal to 9. So sum equal to 10. 10 is greater than 5. So what should we do? We should decrease the j value, j minus minus, because this is a sorted array. If we keep the lesser value, we should decrease the j value. So I am just decreasing that value, j value. Now the j pointer is in the 4th position. So the sum equal to 1 plus 6 is again 7 is 7 greater than 5. So the j value again decreased. And I am decreasing the j value. Then the j value become okay. The j value become 3. Now I am checking again 1 plus 4 equal to 5. Now what happened? Sum equal to 5, then it equal to target value t equal to 5. So this one is correct, this is wrong. Okay, then so we should store this number 1 1 and 4. So target equal to t, so we want to store this two inputs. After getting this sum equal to the target value, we just want to increase both of the like I pointer and j pointer. And j point will be third position. So we just increased the we just increased the I and j pointer. Then I equal to 2 and j equal to 3. Now we are checking that values I value is equal to 2 and j value equal to 3. Then it should become the sum equal to 5. So again the 5 equal to target value. So it's a correct answer. So we should again store this value. And we are increasing both I pointer and j pointer. Now it's become, now checking that we have already have a condition in less than j. So does it condition satisfying? No. So when it will happen, the loop will exit and we got our answer. This is a two-pointer approach. And I'm just coding this here to understand that a pointer I equal to 0 and in j pointer equal to n minus 1. What is n minus 1? N is actually n equal to dot length. So I'm checking that while I less than j, I'm checking the condition actually. What is if my sum value a of I plus a of j equal to target value t, then what should I do? I just want to get that value to the our answer list. So answer dot add I a of I and answer dot add a of j. Then what should I do? I just want to increase both I and j, and I plus plus j plus plus, and closing the if loop. Then after that have again condition as if of what the condition, if a of I plus a of j is greater than target value, then what should we do? We want to, what's the condition right now? We have that value, but the target value is greater or some value is lesser. So we want to increase the I value, then I plus plus. Else there is a condition, if the sum value is greater than the target value, then we should increment the j minus. So this approach we are using in our foursome problem. Not in this similar way. There's a little different. In the foursome problem, we are actually using 4-pointer in our problem. So let's discuss the live code on the LeetCode. So we can move into the foursome problem. For performing two-pointer, we must want to sort the array. So coming to the two-pointer approach, we have array A of some elements. We have the target is equal to 0. To find the unique quadruples in an array of foursome, we want to use two-pointer approach here, but we can be able to use two-pointer instead of using 4-pointer. So we are initializing 4-pointer I, j, l, k. I equal to 0, j equal to 1, l equal to 2, and k equal to last position of the array. Previously we did solve the two-sum problem using two-pointer approach. Here we are actually using the same two-pointer approach to solve the foursome problem. Let's see how we can solve the problem.
Here we have our array, and the length of the array is 6, and the target value equal to 0. We want to find the quadruples, unique quadruples in this array to the total sum of the quadruple equal to 0. Totally looking into this array, we can get 3 Unicode triples, the answer target equal to 0. So let's check how to solve this. Before going to solve the problem, we should want to sort the array because we want to perform the two-pointer approach. Yes, we actually sorted the array. Then the answer become sorted array become like this, and total length is equal to 10. Looking this area, we have our array. We are actually setting the first two pointer of the quadruples here. So I just putting I pointer in the first position, 0th position, and the second pointer in the first position. Then I just want to add one more pointer in the second position, and the uh, fourth point I am just adding here. And how here two-pointer approach will work? We are actually only take the R and L pointer to perform the two-pointer approach. We are fixing the start two pointer. I and J is fixed point, and we are moving the two pointer of R and L pointer. And this is a basic idea of finding the Poisson problem using two-pointer approach. Point I and J. So we should stop the iteration before the length of the quadruples. So the I should go to 0 to n minus 3. Why 0 to n minus 3? This is a 0 based index. That's why we are taking the n minus 3. And the j should become j equal to I to n minus 2. Then the r should go to j plus 1 to n. The I and j pointer are fixed right now. The I equal to 0 and j equal to j plus 1. Now I pointer in the 0th position, j pointer in the first position, and the L point R pointer in the second position. 0th position of I equal to minus 2, jth position 1 equal to minus 1, Lth position 2 equal to 0, and rth position, we are taking the rth position in the last element, last position in the array. So sorry, I just made some mistakes. I just changed the pointer. That's not a big problem. I just interchanged the L and R pointer. I just described the table using A of L and R. So I just changing that. Then there are some is actually minus 1 is actually lesser than the target value. Then we want to get the greater value. So we should increase the L pointer. Why? Because the sorted array, the less position must be greater value, right position is lesser value. We want to get the greater value, we should increase the left side, and if we want to get the lesser value, we should increase the right side. That's the thing actually we are doing here. Yeah, we should increase the L pointer. Now we can see that the next sum will be equal to minus 2 minus 1 and 1. What happening here? Like as per our condition, the a of L becomes 0. Why it's 1? The next pointer. Just check it. Because uh, we actually avoiding the duplication. It's a sorted array, we can easily avoid the duplication. That's why we are actually adding a check condition in the pointer L. If the previous element and current element is same, we are actually skipping that and we are going to the next value. That's the thing happening here, that because of we are not taking this value, and we are changing the position of L, and now the position become in the fourth position. Now the sum of the all quadruples in I, J, L, R point are minus 2, minus 1 and 1, 2. Then the sum of the quadruples equal to 0. So the 0 equal to target. Yes, this is 0 equal to target. The answer is yes, and we are storing the quadruples in our array list. So we got the our first quadruple here. Yes. If we get the first quadruple, what should we do? We want to decrease the right pointer and we want to increase the left pointer. Now we are increasing both pointer here, and we can see that if I'm increasing the L pointer, the L pointer should go into the last pointer and R pointer come into the fifth position. Now we are checking the condition. While the L pointer is lesser than R pointer, no. So what should go? Exactly exit the loop and go into the next iteration. In the next iteration, this J loop start iterated once more and the J become 2. Then we are resetting the L and R point. Now we are adding the elements in the array, the quadruple points. Now we are checking that is the sum equal to 0. Yeah, currently the sum equal to 0. Yes, it's currently sum equal to 0. Sum equal to 0. Then we got another answer and we are storing it in our array list. Also we are performing the increasing the left pointer on the right pointer to perform the two-pointer approach. Now our pointer is just moved to on it, yeah, like here. So the condition should exit and so what happened next? We are looking at we are increasing the I pointer also. I is increasing 1 point and J is going to the J is in the 0th position, L is in the 0th position and R is in the last position. So currently we are taking the sum minus 1 0 0 and 2 is this sum is equal to the target value? No, the quadruple is not equal to target value and the sum is greater than the target value. We should decrease the pointer. Here currently our sum is minus 1 0 0 1 and we are getting the quadruples of minus 1 0 0 1 and here we got an answer again. Yes, it's a quadruple having the sum equal to 0 and we are storing it. Yes, we are storing it. When the condition is over and it exists on the loop, then again checking the I can move up to n minus 3 position and J pointer the previous pointer equal to J current pointer. Yes, it's current pointer, so we are skipping that pointer we skipping that point and moving to the next pointer here and then looking in that we can able to fix that point, so the condition become over, so we are exit from the loop and finally we got the 3 answers.
Let's go to the LeetCode.
So here we have the foursome problem in the LeetCode problem foursome here. The question is given an array nums of integers returning an array of all unique quadruples a of nums of a, nums of b, nums of c and nums of d such that 0 less than or equal to a comma b comma c comma d less than n, a comma b comma c and d are distinct. Then the sum of a num of a plus num of b plus nums of c plus nums of d equal to target. You may return the answer in any order. There is an example, we discussed the example previously and there is also same example here. So in this example there is all values are duplicate, so we have only one quadruples, sum target equal to 8. That's it. So we are doing the live coding. Before in this problem we should give an output in the list. So we are creating the list for storing our answer. So list answer equal to so we are getting the list. This is equal to no array list. Now that's it. Then we are taking integer n equal to our length of our array is nums dot length. Then also we are checking that if our quadruple length, the array length is lesser than the quadruples, so what should we do? We should return the empty array, the empty list. So that's we are doing here. If the array is empty, nums equal to null, or what else, the n lesser than 4, then what should we do? We actually return our result. Yeah, that's it. And we want to sort the array for performing the two-pointer approach, and arrays dot sort of nums. We are sort the array. Then initially we are fixing the two-pointer I and j, and I'm doing here for and I equal to 0, I less than n minus 3, I plus plus. Then we want to avoid the duplication, so I'm doing here, and we are just avoiding the first condition. If the I value is greater than 0, and we are doing that because we want to check the previous element and current element, so we just avoid the current we just avoid the initial condition, initial point. We just we don't consider the initial point. So if I greater than 0 and nums of I equal to nums of I minus 1, then just continue. Just continue. Then after that we just want to fix a second pointer j for int j equal to I, j less than what point n minus 2 and j plus plus. That's it. And also we want to avoid the duplication for here. If j greater than I plus 1 and nums of j equal to nums of nums of j minus 1, and again we just doing the ignoring the condition. So here what happened, we are just ignoring the duplicate part and moving to the next point. After that we are initializing the int L pointer L equal to j plus 1 and int R equal to n minus 1. That's it, and we are opening our while loop for performing the two-pointer approach. While while L less than R, we are opening our while loop and we are taking the int sum equal to what? Sum equal to nums of sum equal to nums of I plus nums of j plus nums of L plus nums of R. Yeah, then we are checking the condition if sum equal to target sum equal to target, then what should do, we want to add this answer in our list. Then result dot add, we are adding as an array, so arrays dot as list of like our answer. Comma. So we just added our quotables in the list. Then again perform, we just want to increase the L pointer and the L pointer and decrease the R pointer, and L plus plus, then R minus minus. Yes, so we did check the condition and we are moving to the next condition. Before that, we should want to avoid the duplication. So what we do, if the next pointer is the same the previous, then we should increment the L pointer to avoid the duplication of the L pointer. We want to check if the previous element equal to current element. We want to increase the L pointer. Similar to R pointer, we want to decrease the R pointer. We are doing here. So while L pointer L less than R and nums of L less than R and nums of L equal to nums of L minus 1 Then we are implementing the algorithm. Similar, the R pointer plus 1, we are decrement the point. So the condition we have checked, we have fixed the condition. So we are checking the while loop, while loop condition. Then we just want to check another condition. Else if what if the our num value sum is greater, sum is lesser than the target, sum lesser than target. Then what should we do? If some value is less, target value is greater, then we should increase the point. Then L plus plus else we should decrease the R pointer, R minus minus. That's it, folks. We are closing our while loop and we are closing and we are returning the result. Return arrays. Yes, we are returning the result. We just want to check that once again. We are storing a result in our list of integers, and we are getting the length of the array, and we are checking that if the array is empty or the length is lesser than the quadruple, we are directly printing the result, and we are sorting the nums array for performing the two-pointer approach. Then also we are setting the initial point I, and we are fixing the I pointer and the J pointer, and here this condition is using for skipping the duplication. Then after that we are fixing the L pointer and L pointer equal to J plus 1, R pointer is the last pointer of the array. In the while loop we are doing in the two-pointer here. We are taking the sum of the all the quadruples, and we are checking if the sum equal to target. We are directly added to the answer if it is yes. Then we are incrementing the not I. It's actually we are incrementing the L pointer and decrementing the R pointer, and the L pointer less than equal to R and the right pointer is less than R. Less than target, we are incrementing the L pointer is R pointer. Yeah, we just want to go into the run part. We are getting the wrong answer. Why? Test gets you expected 222, and we are getting a duplicated element, right? So we are getting duplicated element here. So we just want to check here. 4 into I equal to 0. It's fine. For j equal to okay, yeah. We are assigning the same value in the j pointer. This should be I plus 1. So we are checking this again. Yeah, currently we got accepted to the test case 1 and 2. Okay, then I'm just submitting this answer. Oh, we got again the wrong answer. Why? Because is the integer maximum. Okay, this is an overflow problem. Overflow. That's why, because getting the wrong answer. We should, for avoiding the overflow, we are adding a special condition here. If target equal to integer minimum and target equal to the integer maximum, we are returning the result. That's it, folks, and we are running it. This is accepted and we are submitting the solution. Yes, it's submitted. It's fine, perfect. Now we are coming to a time complexity and space complexity solution. For I and j, it should be of n square. Then coming to the while loop, as we know that we are actually sorting the array. This cost of n log n. So the n log n is way much lesser than the n square. So we only take the n square, and in the while loop we are only iterating the L to R, and also we are avoiding the duplication. For the large input, it should the time complexity is equal to of n square. What about the space complexity? We are using the array list, so space complexity become of n. That's it, guys. I hope you guys understand the approach, and see you in the next video. Till then, bye, take care.